So I would like to go on and introduce Abdelmalek Bahri from Mayekawa. And so Abdelmalek is engineer, so he has Master of Science and in simulation and process engineering with a specialization in heat pump technology. He worked in different companies, has experience in technical simulation and sales of heat pumps from energy providers and also from heat pump manufacturers. And now he's working for Mayekawa. We are very much looking forward to your view and your products that you can provide in this field. So please, Abdelmalek, it's now your turn.
Yeah, thank you, Mr. Apagos, and thank you for the invitation for Mayekawa. And in the last year webinar, what's very interesting also, our research partner, the TNO, they showcased our first fuel-scale industrial heat pump producing steam above 140 degrees. And for me, it's interesting. I'm also excited to share new insights in how we are advancing in decarbonized steam solutions with some real project examples. So who's Mayekawa? I will give you a slight overview of our company, then directly going to the overview of high temperature heat pumps. What units are we offering? What kind of compressors? And the third point will be two real project examples, one which we also delivered and one which we will deliver in the next months, and the use case, and at least a summary to the characteristics of our heat pumps. So first, an introduction to Mayekawa. Mayekawa is a family business company founded over 100 years ago, so we have a very, very long history by Kisako Mayekawa in Tokyo. And the current CEO is now Shin Mayekawa, so it's still in the family. The business, what we are mainly doing and selling are compressors, so different kind of screw compressors, piston compressors, up to 6,000 pieces per year. We are around 5,000 employees in 40 different countries. Two main technologies: the piston compressor, which we introduced in 1924, and our screw compressor in 1964 for different applications. We have a headquarter in Belgium, which we founded 50 years ago. There we are doing the main being for compressor and spare parts, but also the packaging and building the heat pumps, chillers, and also our steam generating heat pumps are coming from our manufacturing in Belgium. This is a factory in Serbia. Here we are doing our chillers. So we have Sirius chiller, the M chiller brand. We have our M heat brand. We are doing standard ammonia heat pumps, not the high temperature steam generating heat pumps, with different compressor units. And we we spread these units, sell these units in Europe, Middle East, and North Africa. So this is our factory in Serbia. In Germany, we were founded 15 years ago. So we have a headquarters in North Rhine-Westphalia. We have our own workshop and our own storage facility. We are around 30 employees. And what we are mainly doing here is the sale of the compressors, our compressor units, the packages, so the chillers, the heat pumps, the standard heat pumps, and the high temperature heat pumps, as well as the steam generating heat pumps. And we are also doing the after sales service, which includes also the overhaul of the compressor. The Mayekawa has different brands. You can see here from Mycom, this is a brand where we go today deeper to see which heat pump units we are using, which compressors we are using for our heat pump units. So we are using our own Mayekawa heat pump compressors. But you have also slightly other brands like DAS, Chorus, M Chiller, M Heat, and Unimo. For us, it's interesting now to have a look on the high temperature heat pumps. A quick overview of our high temperature heat pumps. You can see here a graphic. On the x-axis, you can see the heat output. On the y-axis, the temperature which we can produce from our high temperature heat pump. We have two types. which I want to present for you today. The first one is a FC high temperature heat pump, where we are using a screw compressor and the refrigerant pentane or isopentane. We have different sizes of this screw compressor, and depending on the size, we are able of producing starting by around 400 kilowatt up to 3 megawatt. Surely also depending on the temperature lift, as you could hear in the presentation before. We are able with a refrigerant pentane to produce around 160 degrees steam. It's a maximum output. Depending on the temperature, we can also use isopentane. So depending also on the temperature, by a slightly lower temperature, isopentane could be rather better than pentane. That's our screw high temperature heat pump. Our MHD high temperature heat pump is a piston compressor. What we are doing here, we are using butane for achieving temperatures up to 130 degrees on the heatsink outlet. We have different sizes of our compressor, so depending on the application, we can scale it from a half megawatt up to almost 3 megawatt. One unit can include up to 2 or 3 compressors, and with this we can achieve this 3 megawatt. What's also very important to say is that both heat pumps are in general working only with natural refrigerants, and it's also very important that we only offer natural refrigerants for the customer, so zero GWP, no global warming potential, 0 ODP, and no PFAS. So that you are able also to have a future-proof investment in this technology and also in decarbonizing your process. Yeah, so the first heat pump I want to introduce is a piston high temperature heat pump where we are able to produce up to 125 degrees of steam. So this is the steam outlet temperature. We can start with a high temperature of 90 degree inlet temperature, and the maximum outlet temperature we can work with is 70 degrees. But we can also work with a heat source outlet temperature of 35 degrees, and even then generate with this low temperatures, low pressure steam. As we can see in the most industrial applications, we have temperatures of waste heat source between 40 or 35 up to 50 degrees. And even with this temperature, we can use it and generate low pressure steam. So this is very important to know about our high temperature heat pump. And we can do it in one stage, which is very, very efficient in the steam production and also in the COP. So the first use case of our MHD heat pump is where we produce low pressure steam with an heat source outlet temperature of 70 degrees. So let's place the heat pump in the center of the process. What you can see is a use case. It could be used for in the cooking process in the food industry, where we need low pressure steam of around 1.5 bar absolute, which we can then use for different applications, such as cooking processes in the autoclave, or in the chemical industry, in sterilization, or in distillation of chemicals, which we only require low pressure steam. On the heat source side, we are able to use different heat sources. We can use a multi-source heat pump, also from Mayekawa itself or from another already existing heat pump. We can also use other industrial waste heat on high temperatures. What we are having here on the heat source side is a 90 degrees inlet and a 70 degree outlet temperature, with a total COP of 5.7. The capacity range, depending on the compressor size and also on the number of compressors we can put on this kit, between 700 kilowatt up to 1.4 megawatts of heating capacity, which is around 1 ton of steam up to 2.5 tons of steam. We are also able to, since we have a modular design of our heat pumps, we are also able to use a bigger delta T on the heating side. What does it mean? We can use, for example, cold feed water, so it doesn't have to be at 100 degree or 90 degree. For example, at 40 degree, as you can see it here, and first produce or first heat up the feed water to, for example, have better efficiency of the complete unit. It's the first thing we can achieve, and the second one is that we can get higher steam output rate. What's also important to say about our condenser, so we are using a shale and plate heat exchanger where we are directly condensing our refrigerant and produce steam. Yeah, so let's go back to the graphic. Now it's time to go to the two real-world projects with our screw compressor. As you can see in the graphic, we are able with refrigerant pentane to produce 160 degree of steam, around 6 bar. Here we are able also to adapt very, very high heat source temperatures, and we can go down up to 50 and 55 degrees heat source outlet temperature. And even then produce, since we are using a screw compressor, we can get a higher compression ratio and produce with this heat source waste heat around 4 up to 4.5 bar of C. Yeah, so here I want to introduce you our project Stella Polaris, where we have from the second stage around 82 degree of heat source and producing 145 degree. Let's go to the next slide. Yeah, so the Spirit project from Stella Polaris, it's a EU-funded project, which we delivered this year. To the project data, Stella Polaris is a world-leading producer of cold water shrimps. And what we can often see in general is in the food industry that cooling and heating processes are simultaneously required. For this example, in the seafood industry, we have several stages of processing the product. Here, this is a shrimp, for example, the cooling by delivering, or the packaging, the thawing, maturing, and the cooking, and also the peeling. So there are different cooling and heating duties in this process. And the task is to decarbonize the complete process. So now what we did here is to decarbonize the steam production. We are doing it here with our FC high temperature heat pump, our screw compressor. And what we can achieve is a reduction of 600 tons of CO2 per year. Yeah, let's dive deeper into the process. What we can see on the right side, we have here waste heat of 80 degrees from an already existing freezing plant. It's an ammonia system which is already there. And what it did, it rejected the heat into the seawater. What we are now doing is that we use the rejected heat by the condenser and use it as a waste heat source for our Mayekawa heat pump. Our high temperature heat pump is a two-stage unit. So you can see on the first stage, we have here ammonium, which we are using. On the second stage is our pentane. The first stage is ammonium, boosts the heat from the 18 degree up to around 80 degrees. In between of our heat pump skid, we have a cascade heat exchanger, which is a combined evaporator and condenser. Here we are condensing our ammonium and evaporating our pentane, which will then be boosted by our screw compressor up to 150 degrees. It will be condensed in our other heat exchanger so that we are able to generate steam by 4.1 bar absolute. 700 kilowatt, which is around 1.2 tons per hour of steam in this project. Also, it's important to say that also for the company, it was important that they have that they only use natural refrigerants and only have a natural solution by decarbonizing their steam demand. Next project is also in the food industry. It's in the Baltic region, and here we're actually doing the same. So we also have both cooling and heating duty. Here we also have a two-stage unit where we start now for the pentane circuit with around 82 degrees. But here we go even higher. Here we are producing almost 6 bar of steam. Yeah, so let's have a look on this case, which we are going to deliver next year in 2026. It's also in the food industry, in the seafood industry as well as the Spirit project. What's very interesting here is that we are decarbonizing the complete process line. So we have here the freeze product, where we have our own micro screw units for the freezing plant. Then we have here the condensed heat of 38 degrees, which will be delivered to our two-stage unit. Our high temperature units will then also have these two refrigeration circuits, the ammonium one and the pentane one. And here we are going higher with our pentane so that we are able to generate steam by 6 bar, which we will also be used in the cooking process by the seafood of the company. Here we are using a much bigger screw compressor so that we are able to produce 2 megawatts of heating capacity, which is around 3 tons per hour of steam. Yeah, the goals here also is that they have a waste heat reduction. Second one is that they're able to decarbonize the complete process, cooling up to the heating side only with the Mayekawa products. And here as well we have direct steam production through our heat exchanger. Yeah, many informations to give you a brief summary. So Mayekawa's compressors we are using are compressor series which are proven with a long lifespan. What does it mean? We use these compressors for many years in different applications. So these are not in new developed compressors for the high temperature stage. We modified them for them, but we have many references with this kind of compressors. Yeah, as I said before, we have efficient direct steam production of our heat pumps. We are directly generating our steam through our heat exchanger. We are also able to decarbonize the complete cooling and heating duty. So from refrigeration, from the standard ammonium, from 90 degrees hot water up to 6 bar steam, we are able to provide a complete solution to decarbonize your process. What's very important for us is that we have the 3-0 politic, which also have many companies like Nestle, for example, we just read before, that we only use natural refrigerant with a 0 GWP, 0 ODP, and no PFAS. We have a modular design for different conditions. So we are able to configure it with different sizes of compressors on one skid. We can even put 2 or 3 compressors on one skid so that we are also able to scale the steam output from a half megawatt up to over 12 megawatt. Yeah, many informations, how to start, especially for the participants here who are consultants or planner. Me and my colleague, Peter Kaden, what we are doing is first that we give you the first concepts of heat pump with a COP, with a budgetary offer with a price, and help you in configuring and also decarbonizing your system. Yeah, that was all. Thanks for your attention. And
thank you very much, Abdelmalek.